All right, so good to be back. My name is Hudson. Welcome back to the channel. Today, we're going to dive into the world of remote access and secure connections with a powerful tool called Secure Shell or SSH. But before we dive in or jump in, we need to answer this burning question. What is Secure Shell or SSH? Well, DigitalOcean is a cloud platform, it's a cloud provider. They define this as a protocol used to securely log on to remote systems. It is the most common way to access a remote Linux server. Another platform, which is Hostinger, it provides hosting services. It defines Secure Shell as a remote administration protocol that allows users to access, control, and modify their remote servers over the internet. So it's about your computer gaining access to some kind of a remote computer, which is a server. You can control, you can modify, you can do whatever you want. So it is a protocol that allows two machines, the client and the server, to communicate securely over a network. Why the use of SSH? SSH or Secure Shell protocol keeps your login credentials and commands safe from hackers. The data is encrypted. Hackers cannot eavesdrop on your information. It uses public key cryptography to verify your identities or the user identities. Before SSH became the dominant protocol for secure remote access to computers, there were several other methods in use. There were several other technologies that were being used. One is Telnet, 1969, is one of the earliest. The downside of this technology was it sent all data in clear text, which you don't want to do over the internet, because there are a lot of people who are prying on your information, and so you don't want to be doing this. There was RLogin, there was RSH, FTP, etc., and all these methods, they were vulnerable to attacks, hence the introduction of SSH. How does SSH work? SSH works by connecting a client OpenSSH client to an OpenSSH server called SSHD. We have a client SSH. This is a computer installed with SSH so that it can be able to send SSH requests. The server on the other end, it has to be installed with SSH so that it can be able to listen to these requests from the client. Then it can be able to process and then authenticate this user and then create what we call a secure connection. There are two ways which you can connect SSH. You can use a password or you can use SSH keys. Our focus is on SSH keys because this is more secure than the use of a password. The requirements, of course, we need a listening server, which is a server installed with, it's a computer that is installed with SSHD. That's our server. And we also need a client computer over here. And then we need a way to authenticate, which is password or SSH keys. So we're going to check on our system. We are the client for now. Let's check whether we have this client SSH installed on our computer. So for you to check that, you go to your terminal. I'm using WSL here, which runs Ubuntu. apt list -- installed. You can see it gives me a whole list of these, and so these are listed in alphabetical order. So just before the P, we have the O here. So I can see I have OpenSSH client right here. This is what I want. It also comes with OpenSSH server. And yeah, by default, most distributions come pre-installed with this OpenSSH client and OpenSSH server. You don't need to worry about that. But in case you do not have this installed, then you can run this sudo, assuming that you don't have these root privileges, apt install OpenSSH-client. You want that to be installed on your computer, but like I said, it comes pre-installed with that. You can also, for other distribution, dpkg, you can check the list of installed apps by running this -l, dpkg-l, and then you run that. We have OpenSSH right up here. So this right here, OpenSSH client and server we have, and so we are good to go. This is for Linux users. If you are on Windows, well, Windows uses a different system. You can use SSH client like Party, or if you do not have those, you can use Git Bash, which is a terminal which comes when you install Git. And so for you to get Git, what you have to do is you go to this website. I'll leave a link in the description. You want to download Git. run the installation. Once you install Git, then you have access to Git Bash. This terminal allows you to run Linux commands on Windows. And so open that, and you can check the installed applications by listing the /bin, which are binaries, the executable on your computer. So if you run that, you will see SSH is right here. This is our openssh-client. This is our openssh server. OpenSSH server is called SSHD. OpenSSH-client is usually called just SSH on this one. So you're good to go. So it comes pre-installed again with OpenSSH. We have a client computer installed with OpenSSH-client, and we need a server and also authentication. So we're going to use SSH keys. We need to learn how to generate SSH keys. So that's the first thing we have to do before we go to create a server. Or if you want to create SSH keys, this is how SSH keys work. You need to pay attention right here, because it's an important part which I did not understand when I was introduced to SSH keys initially. And so I've come up with an analogy of how I understand how SSH keys work. So when you run the SSH key generation, there's a command that you run in your terminal to generate the keys, the SSH keys. There's going to be two keys generated. One is going to be a public key, another one is going to be a private key. And what happens is you need to have this public key on your server. So you copy this public key from your computer to a server that you want to log into. Once your server has this, then each time you want to connect to that server, it will have to compare your private key with this public key. The public key becomes more like a padlock on the server, and then your private key becomes your key to access this server. And so the server will present you with this padlock and say, okay, you want to gain access to me. Do you have the key, the right key to open this padlock? If your computer does have the right key, then you are allowed access into that server. That's how it works. And so take this analogy and use it like that. One, the public key is your padlock. It is open to everybody. Anyone can see. If you have a padlock, right, you can leave it on the door. Anybody can see it. But your private key, don't allow anybody access to your private key. Nobody should gain access to your private key, because once they gain access to your private key, then they can also get access to your server. That's not what you want. You can send this public key to multiple servers, and you can use this single key to open or gain access to those servers. That's the beauty. All right, so let's look at generating SSH keys. So to generate an SSH key, you need to use this command, ssh-keys, and then you provide some flags. You can generate a key based on a certain algorithm. These are some of the algorithms that are supported. You have the RSA, which is reversed, Shama, and Adobe. I'm sure these are the guys who created this RSA, and so they named it using their initials. And then we have DSA, we have this other one, ECDSA, and then we have ED25519. All right, so let's go and generate our SSH keys. I'm going to use this Linux. If you are on Windows as well, you can use this Git Bash. Same commands. It's not going to change. All right, so we want to generate our SSH key. So we say SSH key dash key generate keygen, and then dash T is for the type. And we saw the different types that we can generate. We can generate an RSA, DSA, the ECDSA, and then add 25519. These are the types. If you just say SSH keygen, by default it's going to generate an RSA key. But then we can just make sure that it's generating that. So I'm going to say RSA right here. That is the type of key that we want to generate. If you want to set a number of bits, you can pass in the dash B, and we saw right here the number of bits is usually 2048, right? You might need a longer one with 4096. This is where you specify using this dash B, but we're not going to do that. We're going to generate the standard one with 2048 bits. That's enough. The dash C is for commenting. This is what is going to be appended to the end of the public key. If you do not specify this -c, then this username and computer name are going to be appended to the end of the public key that you're going to generate. All right, so we're going to generate this RSA. That's what we're going to do. Let's run this command. It says generating public private RSA key pair. So 2 keys are going to be generated. Enter file in which to save the key. By default, it's going to be saved in your home directory, .ssh, and this is the name of the key. But I already have this key generated, so I need to change this name. So you can name this key whatever you want, but by default is the ID_RSA. It's good to keep it like this, but if you do have multiple keys, then you want to change the name of this one. So that's what I'm going to do. So I'm going to say .ssh because I'm already in the home directory, which is home Setson. That's where I am, and so I will start from here. .ssh/, and then the name is going to be my_key. That's the name that I'm going to give this key. And if I run this, it'll prompt you to enter passphrase. I don't want any passphrase. The tendency is most people forget this passphrase, and once you forget this passphrase, then you cannot connect to your remote server using SSH. Then it becomes difficult, and so I'm not going to be using that. I just press enter, and then also press enter, and yeah, it's going to generate that key for you. So you can see, if you see this, then you've successfully generated, and so you can see RSA 2048. That's the key that has been generated, and you can see it says your identification has been saved in. This is the private key, and your public key has been saved in. You can see the my_key.pub, my_key. So these are the keys that I've generated. All right, so to check the keys, now we can check. We can say ls home/.ssh, and you will see the keys that you have in there. So you can see my key and my key pub. These are pairs. So what we need to keep is this my key. This is supposed to be here, but this one, the pub, we need to copy this and then paste it on our server, so that our server can recognize us. And this is going to be your public key, which you're going to send to your server so that it knows your identity, and then you keep the private key. And so only if you have this private key can you be allowed access to that server. All right, so once we have this, we know we have our public key and our private key. This is what we're going to use. Now we can go ahead and set up our server. And so the third thing we need from our requirements right here is a server which is installed with SSHD. All right, so I'm going to use DigitalOcean. So like I said, if you want to do the same, I'm going to leave a link in the description so that you can create an account with DigitalOcean, and then you have the first 2 months free usage of this service. And so yeah, try it out. So I'm going to go into my DigitalOcean account right here. Like I said, DigitalOcean is an ocean of computers, and so they named their computers droplets. So right here, I'm going to go to droplets. I'll create a droplet right here. Click on create and then droplets. We're going to create a droplet, which is a virtual computer. And so here you can see this is where their computers are located. This is what we call their data centers. So you have some in New York, some in San Francisco, Amsterdam, Singapore, London, Frankfurt, Toronto, Bangalore, Sydney. So I'm going to go with, let me see, Singapore. Yeah, I want to go to Singapore. It's closer to where I am. And then you see this, there's only one data center in Singapore, but in some places there are more than one data centers. And we need to choose an image for that virtual computer, because a server is also a computer. So we need to choose the operating system. That's the image. And so I'm going to run with Ubuntu and the latest version. I'll leave it like this. I'll leave it as default. Choose size. We're going to go with the basic plan because this is for demonstration purposes. We don't need something bigger than that. So I'm going to go with this shared CPU. And then we go to the regular here, CPU options. We need the regular, and we're going to go with the cheapest. We have the cheapest here, which is $4. So depending on the data center that you have chosen, you might not have this option. So I'm going to go with this $4, which is $4 per month. That's reasonable. It's affordable. And then this one, we don't need to choose anything, additional storage, leave it like that. And then we come here to choose authentication method. There are two ways. You can either use a password or SSH key, but we are going to use SSH key to connect to our droplet, which is that remote computer. So we need an SSH key pair. Right here, I already have some keys that I have added to this platform. So I have this key, Ubuntu SSH key, my first key, demo, SSH video. Yours might be blank here. You might not have anything. So you want to click where it says new SSH. So now we're going to copy that public key and then paste it right here. So we go back to our terminal. This is our terminal. And my key is, I'm going to cat to list the contents. This is the public key. Do not expose your private key to anyone. This thing here is your private key. This .pub, yes, anyone can see it. It doesn't matter. But this, no one should see it. And so what we're going to do is we're going to copy this, Control C, copy everything, copy the whole thing, and we're going to paste it in here. So right click and paste. You can see I've pasted this, and once you see this green tick, then you're good to go. We're going to name this, let me call it my key. And so we're going to click on add. Once we name our key, we have it. So you can see right here we have it. And so what I'm going to do is I'm also going to add a few keys in case things do not work the way I intend them to work. So I'm going to also choose this one. So you can use multiple keys. So I'm going to tick 3 of these, but for you, even if you have one, that's enough. We're going to provide a tag for our server. So I'm going to call it my web server, like that. And now down here we can create our droplet. We are creating our server. Once you do that, you can see our server is being created right here. It will take a few minutes to spin a new server. So I'm spinning a new server right here. Like I said, once you generate your keys, you want to copy the public key into the server. It's going to be copied on the server in a directory called authorized keys. So it's on the server, there's a home directory there, .ssh, and then authorized key. That's where that key is going to be copied in. On DigitalOcean, we did not have to manually, copy it into this directory, but that's where it's going to be copied by DigitalOcean. You can do it manually, or you can use, there's a tool also that we can use called SSH copy ID command. We can use this command as well to copy the key to our server. See right here, we spawned our server. You can see we gave it a tag and it's called my web server, so we know. So our server, the way it works is we use this IP address to access our server. So accessing a remote computer, now we have all the requirements. We have our SSH client, we have our SSH server, we do have our keys, and so now we can use SSH user at host. So the username is the username on the web server. If you're using DigitalOcean, it defaults to root. You are the root user, and so you say SSH root at that server IP. And so let's get down to that and see whether we can be successful in connecting to this remote computer. So I'm going to copy this IP address. This is what we want to use, and then back into your terminal. This is where we created our private and public key. It has to be the same place, same location, same computer. You cannot create your public private key here and then you move to another computer trying to access using SSH. It's not going to work because it does not recognize that computer, because it does not have the private key to open that public key. So you need to keep that in mind. And so once we have this, we can SSH. Like I said, if you want to see what is happening behind the scenes, you can use -v for verbose. And then we can root. Like I said, DigitalOcean uses root as the user. And then we can paste our IP address. So the computer that we're trying to access is this one, and so that's what we have to do. So after we have done this, we can run this to see. So because I passed in that V, that dash V, that's why you're seeing all this information. So it shows you the steps it's taking to gain access. So here you see, are you sure you want to continue connecting? So I'll say yes, run that, and let's see what will happen. Boom, you can see we have successfully connected to our remote computer. So you can see this is the name of that computer. Let's see, right here you can see this is the first one, this one, 01 sgp01. let's see if it's that sgp, okay, sgp101. so you can see that's the computer that we're in. So now I can remotely operate that computer. This is our remote server. So I'm using SSH. I SSH'd into it, and that's it. So you can ls. For now, there's nothing here in this computer, but we can cd up to get into the root, pwd. We are in the root. If we list whatever is in the root, you can see what we have. We have everything. This is our file system, our Linux file system, because we installed Ubuntu. So this is going to be Ubuntu right here. You can check. Let me cd dash so that I go back to my root directory. So you can see I'm right here in the root. I want to cat and check what is in the authorized /.ssh /authorized keys. I want to check what is inside this authorized keys directory. So if I press enter, you can see you'll find our key right here. You find all the keys that we added right here. These are our public keys. This is where our public keys are placed when we added them on DigitalOcean when we were creating this server. So it's going to be added into this folder. This is where you want to add your public keys, so that when you were trying to access then this padlock, it will use this and then check against your private key on your computer, and then you can be able to access this. So we have successfully logged into our computer. If we are to do any installation, run this, etc., then we can do this. All right, so I hope this has been helpful for those who are trying to log into their system using SSH. If you like the video, please leave a like, subscribe to the channel. I hope to see you in our next tutorial. For now, I'm out. Bye-bye.